Good morning and welcome to this video which is dedicated to the Newton's third law. Okay, so this is about Newton's third law, and the focus is that we would like to develop some concept. So this is more of concept development. Okay, which means you have studied the theory and now you're using some concept development material to understand how it gets applied. So I will not say you're solving a problem, but you're developing the concept. That's your stage. So the first stage always is that you must study theory in physics, right? You must understand the theory. And the second step you have to do is to use some concept development material. Okay, concept development material, which are generally very small questions, fill in the blanks, MCQs. It is called concept development material. This is very important. And later I will tell you, what books you have to study for concept development. Okay. But let's come back to the topic of Newton's third law. Now, see, Newton's third law states that, every action has an equal and opposite reaction and they act on separate bodies. So the action acts on the other body and the reaction acts on the other body. Let's see how this comes into practical play. So for example, if you have a space station which is gravity free, and this is your space vehicle, and you have an astronaut here. Okay, so this is the astronaut here. Okay, and this is, by the way, gravity free space. There is no gravity. So this is gravity space, gravity free space, let's put it correctly. Now what happens is the mass of the astronaut is given to be, so let's say mass of the astronaut is 70 kgs, right? It is 70, and the mass of the satellite is 10,000 kg. Okay. Now here is the situation. So this astronaut decides, he's outside the spaceship. He pushes the spacecraft, okay? And when he pushes the spacecraft, the astronaut, pushes the spacecraft. The spacecraft gives a reaction to the astronaut. And astronaut starts going back with an acceleration of 0.36 meter per second square. Okay, so this is the acceleration of the astronaut. Now the question is, when the astronaut, pushed the space ship, let's put some space module, he got a reaction back. So the action was on the spaceship and the reaction was on the astronaut. Okay. Now we know that Newton's third law states that action and reaction, occur as a pair. They always occur together and they act on separate bodies. So let's see what is that pair of action and reaction. So the astronaut gets a reaction back, which means the force acting on the astronaut when he gets towards the right, he pushes the spacecraft towards the left, but the spacecraft pushes the astronaut backwards. Our aim is to find what is the acceleration of spacecraft, right? Which came from the push off. But the law which is being used is Newton's third law. So the force which acted on the astronaut is 0.36 multiplied by 70 newtons, okay? Which means the astronaut got a push back as a reaction of this magnitude. Okay, this is a mass. So the spacecraft, should also get the same equal amount of force because it's action and reaction. And the spacecraft, the acceleration we don't know, we want to find out, but the mass is known to us, right? So this is these many newtons. Now we know action and reaction, occur in pair and are equal and opposite. So these two are equal and opposite. So I put the magnitude, of these two, as equal, and I write 0.36 into 70, which is a reaction on the astronaut, is equal to the acceleration of spacecraft multiplied by 10 raised to power 4. So the acceleration is now given by 0.36 into 70 divided by 10 raised to power 4. So this is 0.36 into 7, into 10 raised to power minus 3 minus 2. And this becomes, 36 into 7, whatever that comes out to be. 36 into 10 raised to power, 36. This is minus 5 and one more 7. So 7 6 are 42, 7 3s are 21, 2 3 2 into 10 raised to power minus 5 meter per second. So obviously the acceleration of the spacecraft has come out to be very, very small. So this is a classic, case where you take, clearly see action and reaction in play. And, so we see before we start venturing into doing, a lot of big numericals, it is very important that, your teacher, spends a lot of time in doing concept development and helps you understand, how the law comes into play. Obviously, this gets more and more complex, as you progress. But I think one of the very important step, after you have done the theory, which you must do in detail, the second step has to be concept development. Do small numericals pertaining to the concept, and understand each law in detail before you venture into, some complicated numericals. So I hope you enjoyed this video. And if you liked it, please subscribe to my channel. And I'm very thankful to you for your kind attention. Thank you very much.